Last video of week 2, differential equations. We're going to do that integration by parts that looked so criminal from the first video. It would look so bad we're going to skip it. But it really wasn't that bad. And this is a Calc 2 idea, Chapter 7 if you took Stewart, for the author of your calculus book. And it's called tabular. It's tabular method. If you ever watch Stand and Deliver, the teacher does a tabular integral during the movie. It's so awesome. So yeah, I can't believe there's a movie with a tabular integration by parts in it. This is integration by parts, tabular method. And it works when you have a factor that goes to 0 after repeated derivatives. And if you notice, you've got a t squared that does go to 0 after repeated derivatives. The first derivative of t squared is 2t. The second derivative is 2. And the third derivative is 0. You have to do an integration of the e to the negative t. So notice it's the original t squared, the original other factor. Now you integrate for each step on this side. That's what integration by parts does. So the integral of e to the negative t is negative e to the negative t. The integral of negative e to the negative t is positive e to the negative t. And the integral for positive e to the negative t is, of course, negative e to the negative t again. These guys over here, these plus and minus signs, they alternate because if you remember the integration by parts formula has the integral of u dv equals uv minus the integral of v du. And we're doing this part over and over again into further integration by parts. So this minus sign distributes across another minus sign over another minus sign, so you get this alternating effect. Well, whether you like it or not, that's what you do. So let's do this thing. We're done. We have it. Because now you stop at the 0, as soon as you got that 0. And these little sweeping lines are the things you multiply together. So my answer is t squared minus e to the negative t. So they're times each other. So negative t squared e to the negative t. Next one is the 2t times e to the negative t times a minus, so I get a minus again. One more, 2 times negative e to the negative t times a plus. So the minus lives there as well. And I swear to you, except for the plus c, I swear this integral turns out to be this. And it wasn't too bad. It was a lot less writing than regular old integration by parts. So that was a pretty quick video, McDaniel. Where's the ferret? Well, the ferret's, she's right here. I'll get the ferret. Ferret. All right. So we got the ferret, and she's going to help us check, because if you've never done a tabular before, you might think this is another too good to be true trick, McDaniel. These things just fall from the sky or something. How do you know these things? Well, I'm a math person. I know this stuff. Anyway, tabular's a good trick to know. You never know when you yourself are going to have to do a repeated integration by parts. So here we go. I'm going to have to, I'm going to take the derivative of this with respect to t, and I'm going to get back the t squared e to the negative t. After I take the derivative, now let's look at this derivative. I've got a product rule, another product rule. Well, no product rule there, and the derivative of c is 0. So let's take the pieces down. The derivative of this is going to be negative 2t e to the negative t plus, because the negative comes down and hits there, plus a t squared e to the negative t. What? What do you want? What is it, man? There you go. All right. Next piece. I have to take the derivative of t, which is just 1, so it's negative 2 e to the negative t. And then this minus comes down, derivative of the power, hits that, and I get a plus 2t e to the negative t. Next, this derivative. Well, there's all that comes down is the derivative of the power, so it's a plus 2 e to the negative t, and the derivative of c is 0. So let's check it out. I have a negative 2t e to the negative t and a positive 2t e to the negative t. They cancel. Boom, boom. I have a negative 2 e to the negative t and a positive 2 e to the negative t. They cancel. All that's left is what I promised you we'd get. t squared e to the negative t. The derivative of this mess is that. So we get the antiderivative correct. Tabular will never be on a test or a quiz for a grade, but the book. Homework problems, maybe once every other section. The book assumes you're not afraid of tabular. So don't be afraid of tabular. It's a nice trick to have, but if you forget it, it's not going to be for a grade. But boy, it helps you do some problems. Okay? Check ya on Thursday night.